Recently, issues in the physical supply chain have been prevalent, from scarcity to complete breakdowns. With all this disruption in the physical world, it seems like focusing on the supply chain for software has not been as elevated in the collective consciousness. Do companies even know what makes up their software products? If they don't know, then that's a big problem, according to Brian Fox, co-founder and CTO of Sonatype. Brian gives us his take on the current state of the supply chain for software and how companies must evolve in how they secure it. Enjoy this episode. IT Visionaries is created by the team at mission.org and brought to you by Salesforce Platform, the #1 cloud platform for digital transformation of every experience. Build connected experiences, empower every employee, and deliver continuous innovation with the customer at the center of everything you do. Learn more at salesforce.com/platform. Welcome everyone to another episode of IT Visionaries, and today we have a special guest. He is the CTO and co-founder of a company called Sonatype. Brian Fox, welcome to the show.
Thank you for having me.
All right, Brian, this is one of the more exciting products that I'm aware of. It's used by, as your website says, 15 million developers, but if you're out there and you don't know what Sonatype is, Brian, can you tell our audience what exactly is Sonatype and what it does?
Sure. So Sonatype, as a company, we started as a company around Apache Maven. Apache Maven is a build tool for Java. It's open source, and it happens to be the most popular build tool for Java. So if any of your developers are developing Java, chances are you're using Apache Maven. We have a number of products largely around what people are now calling the software supply chain. One of the things that we do, not quite a product, but related to Maven, is we run the Maven Central Repository. This is where all of the world's Java open source is basically shared. So again, if you're a company producing or consuming open source Java, you're almost certainly getting it from the services that we provide. So that's one huge aspect of it. And I think that's pretty cool that basically all the companies in the world are using our tech at some level. Our products are largely focused around capabilities enterprises need to manage that software supply chain and to help developers make better choices around the components that they're using to assemble the applications from all different dimensions, whether it's security or licensing or quality and hygiene.
So there's a lot of ways to help that process. Give us an idea of how, like, what are you guys doing specifically that makes it easier? So like one of the things I picked up on just a moment ago, you said is like, hey, it helps you developers make better selections, better choices in the software supply chain as they're building out products and services for their customers or whatever internal applications. Give us an idea of how you help that, or you're a steward of that.
The modern application, and this has been true for 10, 15 years at this point, is composed of about 90% third-party components. Most of those are going to be open source. So your developers in this decade are not writing 100% of the code. When I started my career, we sat down at void main void and we started writing like literally everything. That's not what happens anymore. We assemble the software together, much like physical goods manufacturers. Take a car. They assemble the engine from parts that come from lots of different people. They don't literally get the iron ore, refine it, and print every single thing. That's just not a thing anymore. Software is built that way as well. And like I said, about 90% of the code that you're shipping, somebody else wrote. And again, most of it is open source. And so the challenge has been the industry has not really caught up with that fact and not done a good job of managing those components that their developers are picking. So what happens is you've got inconsistency between different products in your portfolio. They might have different logging frameworks. They might have different UI frameworks. You might have really old versions of it, all these kinds of things. And so what we've been on a mission to do for the last 15 years is to help companies first understand that they have this challenge, get visibility into the components that they actually are using, and then you can start to make intentional choices about that, like reducing the portfolio so that you're not using a whole bunch of different XML parsers or a whole bunch of different UI frameworks, right? And, this follows industry best practices. Edwards Deming is well known for helping Toyota rebuild after the war and focus really on the supply chain and some very key aspects like use fewer and better suppliers. In other words, don't source your pistons from 1,800 different companies. Like that would be insane. Use the best versions of those parts from the suppliers and track all of those things as they go downstream. And the unfortunate reality is that even in 2022, many companies still don't understand all of the components in their software. From a consumer perspective, like I don't think anybody would buy a car from a manufacturer who couldn't do a recall when something is found to be flawed, right? Because we know that that's going to happen and we expect that that's going to happen from our physical goods providers. And yet that is exactly what is still happening in large pockets of the ecosystem with software. So that's what we're trying to help people solve.
I mean, it makes total sense. And you are correct. Over the last few years, especially the last, let's say 10 years, where more and more companies are pushing for speed and the software teams are getting, let's say, smaller or more agile. And you're right, they're not going back to official libraries or anything like that. So like a project can get spun up to augment or build a new product. And who knows what that team will select. That team could select anything. When you think about where you are today, walk back to when you first started this, because this is something that is fascinating to me. Let me ask you a question. Did you see that this was going to be the future, or did you see the problem starting to emerge, or was this more of a hunch and think, hey, we're going to solve for this right now because we're seeing so many people are leveraging open source applications and services and code that there's got to be a better way to manage all these pieces? Kind of give us an idea of where you started with this concept, because that's another thing some of the engineers who have been on this show have talked about before, that they've participated in open source projects in the past, but they're like, how do I turn this into like my service or product that I can get paid for it, right? That's something that some of them always talk about. So give us an idea of when you first saw this problem or thought of this problem, how did you think about it? And give us an idea where your mindset was at that time.
It would have saved me many years if I had the foresight to wake up one day and predict it exactly. So when we started the company, it was mostly, like I said, focused on the needs of enterprises trying to use Maven. At that time in 2007, Maven was still pretty new, but popular enough that everybody kind of recognized like this is the future of how we want to develop our Java software, right? It was disrupting the build systems in Java. Early on, we did a lot of training, literally teaching people how to use Maven. We wrote the Maven book, and then we started providing capabilities and products for enterprises. Like when you're using Maven, it's helping you to assemble these parts together. Maven really transformed that, made it easier to source these open source parts. So one might say it's the fault of this. Like we made it easy, and therefore that's why 90% is composed of these things. But all the languages since then have followed that pattern. So it was the right pattern. But so in the early days, that's what we were focused on. How do we help companies share and source these components? And so I personally spent a lot of time doing training and consulting in those early days with very large companies. It was kind of neat that we had huge name brands that were customers literally from day one. And a recurring theme when I was in there talking to them about how to update their build systems was, we have these corporate policies around what we're allowed to use, not allowed to use. It takes 6 weeks to get approval to use these new things. We're not really sure. Like you've made it possible for us to very rapidly and deterministically build our software, but our corporate structure doesn't reconcile that, and it's in direct conflict with how we've been managing our software before. The state of the art at that time were open source review boards and companies. That might take 6 weeks to approve the new version of something. That's like completely inconsistent. Even in 2007, with where the world was in terms of continuous integration and Scrum and agile processes, 6 weeks is like 3 sprints to get approval to use something. Like that's insane. And so, what we saw was this massive need to be able to reconcile these very legitimate business needs. We need to be careful about the licenses of these components so we don't get ourselves sued and have to open source our code, right? That was happening a lot in the early 2000s. We need to be intentional about the quality. Security was honestly not something that was top of mind. I would push that issue a lot in those early days, and people would say, I've got a security team and a firewall, that's their problem, right? So by looking at that and recognizing that there had to be a better way to capture what was important to the business, but to do so in a way that was not inconsistent with the modern software development, that kind of led to that aha moment, which really took about 3 or 4 years before it really formulated the process for which we build our stuff now.
So that was like 3 or 4 years servicing all these different requests happening around you, and before you started noticing, hey, like there's started to be some unification in the voice of what customers want. Like let's provide that. It sounds pretty.
Yeah, what was interesting was the specific challenges were different in every organization, and that still exists today, right? The culture of the organization and the personalities make the implementation sometimes look a little different, but it took a bit of time to be able to step back from that and say, look, what are they trying to do, right? The lawyers are trying to stop the company from getting sued. That's an important thing. As a developer, it's easy to roll your eyes and go, the lawyers, the security team. But if you're mature about it and you go, look, everybody's trying to do the right thing. The problem is they don't know how to work together. And as the business is expecting software to be developed faster and faster, and it's getting more and more complicated, working together gets harder and harder unless you're able to codify and automate a whole bunch of this, right? And that was that thing that it didn't make sense. We basically flipped the process on its head. The process prior to what we were doing was if you wanted a component, you'd go ask somebody. Let's say it's Bob. I don't know what department Bob is in, but he has a secret list and he looks at it and says, what do you want? What are you going to do with it? And then I'm going to go check my list. It might take me 6 weeks and then I'm going to come back and tell you yes or no. Why does it have to be that way? Like maybe I don't want to ask Bob. Maybe I need an answer right now, and if there's one that's already approved, I'm just going to go with that. So instead of asking somebody and then having to give a bunch of exceptions, we said, well, can we capture the requirements of the legal team? When the software is distributed, what are the requirements? If it's a service, what are the requirements? Same thing from the security team. So when you can kind of turn that around and capture the rules, then you can put it into the system. And so a developer is saying, I'm working on this application. It has the following context. When the application's configured, hopefully you know if it's distributed or not because you're supposed to build it. Hopefully you would know if it's dealing with credit card data or not, right? These types of things are known at that time. Then the right policies can be applied. And so as a developer, you can say, oh, I can't use that component. This component is good. I'm going to use this one. Right. And it saves everybody a bunch of time and drama. Like they may not ask somebody to go do the investigation because they know right up front it's in violation of the policy. Why am I even going to waste my time? Oh, but there's this other one here that otherwise fits my needs. I'm just going with it. So that's kind of how we started to formulate that approach.
So when I was in a software company and I worked, I said, I know how to develop. I can read code. I wouldn't say I know how to write code. I taught myself how to read some of what my developers were doing because I was part of the QA team of a startup. As you know, when you're in a startup, a lot of times everyone wears many hats. I think about the times that this is like 2011 through 2015 timeframe. Our company specifically had the company I worked for had very much this idea that they would start building things from scratch. Like whenever someone's like, oh, we could integrate a link shortener, they'd be like, we'll build one ourselves. Oh, we could integrate OAuth. We'll build it ourselves. Oh, we could integrate, and these are like more at the service level components, not quite at the code level components, but I understand what you're saying. At the code level, you could do certain really cool things too that makes them shareable. I remember it felt fast at the time, like we could ship products still pretty fast, but give us an idea of this like evolution, right? Because it used to be like big long windows of shift that were required to ship code. But now when you're talking about leveraging previously approved, beyond approved, I guess it meets legal requirement, it meets standards, it meets all the requirements similar to, like you said, in a manufacturing supply chain. Give us an idea of like for teams that are using Sonatype for the first time, do they tell you how much faster their development has become? Or do you get any insight as how much time it saves or how many headaches it's reducing? I would love to hear some of the stories you have from development teams that went from building everything themselves or cobbling things together from unimproved sources to like going from a centralized source. Like, hey, we're going to leverage great assets that all of us can take advantage of.
So in 2011, I guarantee you those services your company was developing, you were using a bunch of components. Like there's pretty much zero chance that they wrote every single line of that code. So you were developing new services, but those services were composed of components, almost certainly. Like you can't realistically develop in Java, JavaScript, Python, Ruby, .NET, and write everything from scratch. You just can't. Maybe if you're C and C++, sure. But anything else, it's impossible. And so where we're at now, where the industry is at now, people aren't buying our tools necessarily to go through that build transformation. Like Maven and the things that have come before it, that's almost like a foregone conclusion at this point, right? So they're more agile, they're composing the software. Where we're seeing is when they get tooling like what we have to help them better manage the supply chain itself, they get extra levels of improvements over that. 30% more time can be spent on innovation. and less time on rework. And it sounds surprising, but the old adage is it's always easier to avoid having to fix a bug than to chase it down later. It's the same argument for integrated unit tests, as an example, as opposed to waiting for QA to find it and then rip it out. Same thing for security. So you have less unplanned work and interruption, so you can be much more efficient. Where I think it is most telling, though, in December, there was this Log4j incident, right? I think anybody in tech knows about this challenge, but for the audience, Log4j, very popular, the most popular logging framework, right? So it's one of these kind of boring level components that nobody wants to do. It's like it's a framework for making it easy to write stuff out to logs, right? And it sounds simple, like, can't you just write that to a file? It's like, sure you can, but what about when the files have to be rotated? What about if you need to change the format? What if you want to turn on different levels of logging, right? It actually turns to be nuanced when you've got multi-threaded kinds of things, right? It can get to be complicated. Log4j is one of the most popular frameworks for doing that. It's been around for 15, 20 years, very long time, longer than Maven, actually. And there was a vulnerability found in this that allowed attackers to basically cause your software to download and execute code from a server of their choice. Like, that's the recipe for all bad things, basically. And because it was in a logging framework, one of the first exploits was Minecraft, because you can imagine that Minecraft is logging all the chat in case there are predators and things like this, right? So you pretty much know anything you type into the chat in Minecraft is getting logged, which means it's going through the logging code. Well, people figured out, like, oh, if I put this special string and I type it into the chat, I can cause the Minecraft server to download my code and execute it. And do what? Who knows from there, right? So I think that's the simplest way to see how easy an exploit could be in this particular instance. And so the challenge is Log4j being the most popular. It's used by applications, but also other components might be using it underneath the hood. You could almost safely assume nearly every Java application had Log4j in it, right? And so because anything that you could assume might get logged could potentially trigger this. So it could be typing a username in that had a special string. It could be, hopefully not a password. Hopefully they're not logging your passwords. It could be requesting a page on a web server. Like, any input you could send to a system is likely to be logged somewhere. And so those could be triggers, right? And so this was a very broad, impacting type of thing across the entire industry. Companies that were using our tools that had already understood in their applications all of the dependencies. When that vulnerability data hit, it went into our system. It went out to the customers, same day, within hours of it going through. And the system automatically was able to tell all of the application developers, you need to update this component in your application. And depending on how the system was configured, they may have set it so that you can't cut a release until this is fixed, because it now has like a level 10 vulnerability. We're not going to let you ship it, right? And so we saw companies that had portfolios of tens of thousands of applications basically remediate the amount of things they were shipping, 80% of them within 2 days of the vulnerability hitting the news. So they were 80% remediated within 2 days. People who don't have this tooling, and you could see the Log4j statistics on our website, at sonatype.com/log4j, we started surfacing the download statistics from that Maven Central repository. 36% today, as we're recording this, of the downloads are still of the vulnerable versions, right? So the world, after basically 8 weeks, has still only gotten to about 60% remediation, versus customers that had a good handle on it got to 80% within 2 days, right? And this was during the holidays. This all happened like 2 weeks before Christmas, right? So the discrepancy between companies, or the disparity between companies that have a good handle on what's already inside their system and those who simply have no idea, there are still companies who are basically in a triage phase. They're like going around sending out 4,000 emails to application owners saying, hey, are you using Log4j? The application owner might be like, well, I'm actually not sure. We don't think we're using it directly, but how do you know one of your transitive dependencies is not using it? It's a very hard problem to solve if you haven't done it. And it's a bit like, again, take an auto manufacturer. If they had no idea what brake rotors they put in which car and then there was a recall, what are they going to do? Ask every individual owner, go check to see what the manufacturer is stamped on your brake rotors? Like, give me a break. But that's the situation, right? So the difference between companies that are doing this and not doing it is about that time to remediate and how quickly you can get your systems patched. Because you're really in a race against the attackers when these things happen.
That story was so good. Like your ability to define it in a narrative way that makes it easy to understand. I mean, it makes complete sense. I'm curious why do you think that vulnerability? Because, if we were to look at something like, for example, your Twitter handle, clearly there's a lot of people during this phase of time were very outspoken about this. Now they're, probably more like yourself, very versed in developer, understanding computer science languages from that sphere, right? Why do you think mainstream media didn't pick up on it? Is it because like they can't quantify, let's say this happened? Because this seems like a serious problem, right? Like if this vulnerability is that spread out, you're talking about any tool that, like, Brian, I can't think of a tool that doesn't log chat. Like every tool now, especially consumer to customer, consumer to business, has some type of communication layer. Every company has a communication layer somehow.
I just have to think too many other things going on in the world with COVID. I mean, this came out right as the Omicron wave was peaking, certainly here in the US, so probably that. But I would say it was pretty out there. I had just gotten off a call with a customer. I went and sat down in the living room and I had my cable box on pause and it scrolls through the news. It was there on the news on my TV. So for these types of things, which normally only the developers care about, it was pretty widely disseminated. I think just given pandemic and everything else, it was overshadowed. But the Log4j one, for me, the Log4j vulnerability was a little bit old school. And I mean that simply because this was a set of functionality that had been in there. It wasn't even really a bug. It was a combination of a feature in the Java runtime and a feature in Log4j that, when put together, could cause a problem. Each one independently was not, so it wasn't like somebody just made a mistake in coding. It was a weird combination, a drug cocktail, if you will, on accident, right? And it had been there for a long time. And then somebody figured it out. And then it was a race. As soon as it became public knowledge, there was a fix available. It became a race for everybody to update and consume this thing before the attackers could go around and exploit everybody. And that's what was happening. What we've been seeing, what I've been spending most of my time talking about since 2017 are actually the malicious components. It took a long time, but the attackers finally started moving upstream and focusing more on the open source publishers and on the infrastructure that the publishers are using to distribute to the components to the consumers. And so then what we started to see were not vulnerabilities in legit components that had been there for a while and now suddenly was in a race to update. It was a case of this thing is designed to cause harm the moment you download it. And they targeted other ecosystems like NPM for JavaScript and Python and Ruby, because in those ecosystems, there tends to be less naming validation. Anybody can kind of publish anything they want to the repository. And also, the default behavior is to automatically fetch the latest versions from the repository. And so as an attacker, that's a really sweet spot. I can show up and publish something and potentially have users like instantly. And if I've designed something to instantly cause harm, whether it's do crypto mining or exfiltration of data, there is no time to remediate. In the Struts case with Equifax, everybody was talking about, well, the attack started within the first week of the disclosure. The Log4j one, it started within days. You don't even have days, you don't have minutes when you're dealing with a malicious component, right? And so that's what I've spent a lot of time talking about, because that's a whole nother dimension to the problem, that there is, you can't wait until the software is assembled and then inspect it for quality when the thing might have gone into your development environment 2 weeks ago and has been exfiltrating data this whole time or moving around the network. Like, there are actual attacks where that has exactly happened, and so, taking it back to the Deming thing that I mentioned in the beginning, right? Those principles, if you take it to the car analogy, those principles are things that we expect everybody to do. They are about building better, safer, and cheaper cars. It's about the product that is being shipped out, but it is not doing those things, better parts, better suppliers, and tracking them, does not inherently secure the factory. It's not stopping a suicide bomber from trying to blow up the factory. It's about making the cars better. And so when you're dealing with malicious components in the supply chain, that's kind of what we're talking about. If you have a traditional application security portfolio or program that is trying to scan and assess things before you put it into production, before you ship it to customers, Okay, that's important. You should do that. But it completely is going to miss all the malicious components that are happening on the developer side. And another analogy that I think the audience will probably remember in the 90s when browsers were really vulnerable, right? And if you went to the wrong website because you typoed the website, you might have gotten hacked, right? And the problem was at that time, the behavior was, I went to this website. Whoa, that's not what I thought I was going to find at this website. Let me back up and go to the other website. Well, you just got hacked. And you don't think anything of it because you're like, whoops, I'm just going to fix the error. That's what's happening with these malicious components. So the components are not even trying to pretend to be the real component. They're not trying to pass unit tests. They're not trying to get themselves distributed into production. They're saying, developer downloaded it. I'm exfiltrating information like as soon as it's installed. And so the developer might type the wrong thing. They get the component downloaded. They just got hacked. Their build fails and they go, what happens? Oh, I meant an underscore, not a dash in this component name. Let me fix it. My build is good and I move on with life. But nobody realizes they just got hacked. It's exactly the same paradigm that was happening back in the old browser days. And so to counter that requires a whole different way of thinking about the problem. You can't just keep doing the same old scan it at the end and it's going to fix it.
Yeah, I remember those days. And when you would go to the wrong site and all of a sudden your computer would have like 5 million pop-ups and like you would have to like wipe your machine. Like your machine would become almost useless because every time you went and did try to do anything, some type of pop-up, some kind of ad would take over your screen. It was
precisely.
It was the Wild West, right?
That is exactly what's happening right now with these malicious types of attacks. And there was one type of attack that was disclosed last year. A white hat researcher had done this and collected bug bounties from places like Tesla and Microsoft and I think Netflix. There was a whole handful of them. It was called dependency confusion. That one type of attack, just Sonatype alone, we have reported and had taken down from repositories like NPM and Python, 63,000 components in the last year for that one type of attack. There are many others, but there's just this one. And so in 2017, when I started talking about this, it was sort of a trend and I was kind of laying out almost like a case, like this happened and then this happened, 10, 15, 20 things. And it was starting to show a trend. Now we're dealing with hundreds of thousands of them in a couple of years, and people still haven't gotten that message. And worse, they're not even in a position to deal with what I call the boring log4j thing, the thing that has been basically the paradigm since basically forever. That's the situation that we're in the software industry right now.
So the stories you just told reminded me of a couple previous guests, and when they talked about some vulnerabilities, like you had mentioned test environments or dev environments, how sometimes dev environments actually have the mission critical data already there. So it's like, hey, you're running. So like people might think, oh, I've got my production protected. It's like, except you ran it in dev and test already has production grade data, so they're copying it from there. They don't need to go to prod.
It's worse. It's worse today because in a continuous delivery world, you have automation that is probably pushing to production, which means somewhere in the development systems on those CI/CD servers are actually the keys to the runtime. Right. And so when the things get in there, it's not that hard for them to hop. So yes, what you said, it may have access to copies of the data, but actually it's even worse in a lot of cases now because that same thing, developer can commit the code and then it's just machines on top of machines after that all the way to production, which means, you can pull the string and get all the way through.
And then the other thing was like some of the cybersecurity companies that have been on the show, they've talked about the sophistication of attacks, how they might be, I'm thinking about some of the sophistication that we've heard on this show using what you're talking about, right? Like you make one name entry incorrectly, you accidentally implement a software, but some of these codes they talk about, like they like lurk, like they don't actually change any configurations, and they're like all of a sudden they're slowly like building itself up, and like how they're siphoning data off over a long period of time, like they do it in a way that I guess is very difficult to notice.
Yeah, we saw one. This was it's a couple years old now, 2018, I think it was an attack on a Bitcoin wallet company called Copay. And what happened? This was sort of a long game attack that the attacker found the component. Presumably they figured out that they had a target in mind, and they figured out one of the dependencies that target was using, most likely. I'm speculating, but it's the only way the story holds together, really. And then they found the component that had one maintainer, which is true of a lot of open source projects. Not all of them. Log4j has a big team around it, but there are a lot of small projects that's just one person working on it. Found that and then started contributing fixes to it, and then gained the trust, and then became able to actually publish a new version. They then added another dependency, added another layer of indirection, and added, and what turned out later, took a while for everybody to unwind this, was an encrypted patch file that was targeting to patch proprietary code within the Copay website, right? So what they basically did was they took over one of these small open source projects, then released versions that millions of people worldwide were using, but it had one target in mind, right? And it was very suspicious. As this was unfolding, there were a lot of things that didn't make sense. People are like, what is this? Why is this here? We don't understand what this code is. It's not like they added crypto into the thing. It's literally like this thing is patching a file. Nobody knows what it is. And then eventually it came out what the target was. So that's a pretty high level of sophistication. That's not just after a spray and pray kind of attack or a phishing type of approach like we see with many of these. That was choosing a target, finding the way to get into it, polluting the well when actually you're just trying to poison one person. And for everybody else that was consuming it, it didn't do anything because that code didn't exist on their system, but lots of people were getting warnings. And it was one developer who was trying to figure out why am I getting this warning in my logs, who started pulling the thread that ultimately unraveled and the world figured out what had happened. So the level of sophistication and the time that they have on their hands here really works against us as an industry.
So give us an idea, we're coming close to the top of the hour. How do you envision the future of software development? Because this is where things, I always lean towards the positive, right? And I think you do as well, right? Which is like, so how do we keep progressing? Because ultimately progress is what this world keeps pushing for, right? So we know things that we know are true. One, people are going to want to ship products faster. We all know that's true. That's never going to stop, right? Two, bad actors are going to want it. And bad actors are going to want to ship products faster too, right? So those two things are directly against each other. So how do you build a world where these, one can be true, which is we want to ship great products faster, but you're also simultaneously killing off the bad actors or preventing them from doing what they want to do? That's really what you're probably going to be facing the next 5 years. And if you don't think so, tell me what you think you will be facing in the next 5 years, because we'd love to hear what you think the future of software development is going to look like.
I think these follow the same pattern. If you go back 100 years, 200 years, tainted food was a thing because there were no rules in place, and it wasn't generally accepted that when you put a label on something that it had to be true. Weights and measures were tampered with. And so I think just human nature is not to act until we're kind of forced in many cases. What I would say is the good news, the attention that Log4j, this vulnerability event that happened across it, and going before that, SolarWinds came out around the same time the year before, right? SolarWinds was the first time we saw lots of people, including mainstream media, really talking about the software supply chain. This is something we've been talking about at Sonatype going back to 2010 at least. So it raised the awareness, right? And we saw people starting to act. Log4j raised the awareness again. There was testimony before the US Senate a couple weeks ago on this topic. So people are starting to pay attention. I hope that as an industry, we get our act together before legislation that is maybe over-rotating causes more harm than good. But if enough people don't get their act together, that's exactly what's going to happen. So the good news is that the attention given to this and the general remediation, while only getting the 60% after, what are we at now? We're at like 10 weeks post, is pretty terrible. But it is still better than previous vulnerabilities that we saw before. So we are getting better and more people are hearing the message. I wish everybody would get with the program right away, but then I wouldn't have much to talk about on podcasts, right? So that's why we spend so much time trying to educate, because I feel like if you could see the things that I see, it would immediately change your behavior. There's no way to consider, doing application security the way you did 10 years ago when you understand this malicious attack risk that I was talking about, because you simply can't defend against it that way. And how do you just ignore it? You can't ignore it. So it starts people thinking down the path that I think leads you to those logical conclusions. And we don't have to reinvent the wheel. Industries before us have this solved, right? Food can be recalled and traced. Auto manufacturers can do it. The planes we get on can do it. We just have to follow the same patterns. It's not actually that hard. What's hard is getting people to see what they don't see at the time.
You kind of reiterated a long-standing adage, which is always people are the problem. It's never really the systems and the things, it's the people. Right? And then sometimes it's like the adoption of the behavior is actually the problem. And well, Brian, it was awesome having you on the show. Thanks for sharing that story. I'll tell you what, you're a great storyteller. So your ability to I guess, present that what happened in Log4j, I mean, the examples you used made it really easy to understand. I think a lot of our audience probably got a big kick out of hearing what you just talked about. Maybe they get a little scared, but hopefully if they're one of the 40 percenters, hey, go fix the problem, man. But before you go, it's time for the lightning round. The lightning round is brought to us by Salesforce Platform, the #1 cloud platform for digital transformation of every experience. Brian, this is where we ask you questions outside of the world of work so our audience can get to know you a little better. Are you ready?
Let's do it.
All right. When you were younger, what first got you into software development?
First got me into software development. Well, I assembled a IBM PC clone out of parts when I was, 6th grade, and started hacking on things like that. I ultimately ended up majoring in computer science because at the time I wanted to be a pilot, Air Force pilot, and they were guaranteeing scholarships if you took computer science, which seemed weird to me. So I'll go to school and learn computer science. And, I was having fun hacking on the computer all the time. But the whole budget shut down back in the Gingrich-Clinton days, canceled all the scholarships. So I ended up not ending up in the Air Force and continued on doing the software. So that's how, a little bit of a roundabout way.
So you've been building and tinkering with machines since 6th grade.
Yeah. Yep.
That is wild. What other things bring you a lot of joy? Because you love building, but what about outside of the world of software? Is anything else, any hobbies, any things that bring you a lot of life and passion?
I'm a do-it-yourselfer. Shocker if I built a computer in 6th grade,
yep,
right? Do-it-yourselfer. That keeps me plenty busy. I love to be outside, hanging out. I'm a Boy Scout leader, love going camping, love taking my kids out fishing and hiking and skiing. So all the free time I spend now is usually away from tech as much as possible to try and find a good balance.
Awesome. What's the coolest thing you fixed or built besides a computer?
Oh, I don't know. The coolest thing?
What gave you a sense of accomplishment where you're like, dang, that was pretty cool. I just fixed or built that.
Well, my daughter had a Girl Scout project for one of her higher awards, and we built a kiosk for a trailhead that'll probably be there for the next 50, 60, 70 years, which is kind of cool to be able to look at that and go, yeah, I routed the letters on that sign. It's a small thing, but, I drive by it once in a while. It's kind of cool to see. So I'll go with that.
That's pretty awesome, actually. How big is this kiosk?
Oh, 8 foot long. It's a big bulletin board with kind of 3 sections and a little roof to it and some glass, to lock the papers up and stuff like that.
Hey, listen, the only thing I've ever done is installed a dishwasher. So that seems pretty cool to build a kiosk from scratch. I've only fixed things. I've never built anything. So you're a builder. That's awesome.
Yes. That was a fun project.
Brian, I want to say thank you for joining us today on IT Visionaries. It was awesome hearing your story. And your analogy to the automotive industry or the food industry it makes complete sense. If I'm in software, and by the way, every company now in the world is a software company anyways, because every company has some type of layer that they use where they interact with people via mobile or computer. Like every company is also a software company. It makes total sense that if there's a problem, they should be able to fix it fast, recall it fast, and it should have the least amount of impact on us as consumers as possible. And for those who are in software development, which is a lot of our audience, we know, like you just said, people borrow components all the time. And if you don't have a way to control that, especially with the velocity our modern work life is, where people are in jobs for, let's say 2 years and they go to another place. Like it's very easy for you, like you said, it's very easy for you to oversee a project where you actually shipped none of the code and you're like, I don't know where any of this came from.
That's exactly right.
Thanks for joining us today on IT Visionaries, Brian.
Thanks for having me.